speech and to attribute them different letters. When we see this map, of course, we could think that the connection between these areas must also be changed. And I'm happy to say that with new methods for identifying the connections of the human brain, we can also track these changes. We can see, even in a living person, all of these fiber tracks that connect different brain areas. We can see their microstructure. And what we see is that, indeed, this particular connection bundle which exists in all brains is reinforced and is being changed in people who have learned to read. And there is a good likelihood that this bundle is involved in connecting the letters to the sounds bidirectionally. When you hear a sound, you can also think about these letters. This change is subtle, but it is an anatomical change. So the anatomy of the brain is also changed because children learn to read. We make these essential changes that, of course, create a whole new modality of input of language. There are lots of things we've understood about the details of this process. I want to give you a few. The first thing is, what does this area do before we learn to read? It's, of course, not an area that has evolved for reading, so it must be doing something else. And what we have found is that this region reacts also to faces and to objects. It is involved in visual recognition in all species, actually, in all primates at least. And what we find is that as you learn to read, so this is reading score on the x-axis here, what you can see is that the response to strings of letters increases in this area, but the response to other categories decreases. So there is a sort of competition in the brain of the reader, and the new function of reading has to find some space in the cortex, making room, as it were. And what we find also is that the representation of faces is therefore displaced to the right hemisphere. Words compete with faces in the reader's brain. It's not a massive computation, but it is a sort of reorganization which takes place when children learn to read. Thanks to this understanding, we can also explain puzzles of reading acquisition. And one puzzle which we have been able to explain from the brain's point of view is something you might have seen in your children, which is this notion of mirror reading and writing. Many children, when they sign their drawings, will write their names in the improper direction, from right to left in this case. Here is another example of a child who has written Theodore ti voglio bene, okay? And the child is writing left to right to left, alternating in a writing system which is called Boustrophedon, which means how the ox plows. This was the way of writing in ancient Greece. But of course, children don't know about ancient Greece at that age. So how are they capable of doing these things? And many parents think, is this dyslexia? Well, we understand now what it is. It is not dyslexia. What it is a trace of this old function of the system which is trying to learn to read. All primates have a symmetry mechanism which allows you to notice that these two faces are the same person, even though on your retina they are completely different pictures, but they are mirror images of each other. And this is an evolved system that we have to unlearn as we learn to read, because it is not useful, and we have to distinguish these things as two different words or potential words. We have found indeed that the primary area which has the most sensitivity to this symmetry is precisely the area that I've called the brain's letterbox, which is trying to learn to read. So essentially, it's not a wonder that children have difficulties with mirror reading and writing. This has nothing to do with dyslexia. It is a universal difficulty for all children that they have to overcome, and we might teach them explicitly by the gestures of writing to help them to overcome their difficulty. Another thing that we understand a little bit better now is this very classical question of phonics versus whole word training. You know, there's been a lot of debate in psychology and in education. Should we teach the whole word level, or should we really teach every single letter and their pronunciation? Is there anything such as the global shape of the word which is being used in reading? Well, here there is something very important. As adults, we have forgotten how we were as children. We have forgotten how difficult it was to learn to read, and we think that we can just lay our eyes on a word and it immediately pops to mind. And indeed, there is this notion of parallel reading. We read all of the letters at the same time. This gives us an illusion of whole word reading. But in fact, if we look at the brain still processes every single letter and does not look at the whole shape. So whole word reading is a myth, basically. What we have is letter processing, but letter processing in parallel across all of the letters of the word. The brain does not use the global work shape. And in fact, in children, it's even worse. Children require more and more time for more and more letters. You can see this on this graph. This is the number of letters in a word, the reaction time of the children. And in first grade, they're very, very slow, and they need more and more time for each letter. So this is not at all whole word reading. It's slow, serial, one letter at a time. And as children progress, second grade, third grade, this goes away and gives this illusion of whole word reading. So I think we can be very clear on this point, because there is a strong convergence with educational research to suggest that the brain has nothing to do with this sort of exercises that my child had of picking up the ascender and descender letters and deciding that this corresponds to this word. The global shape is not used. Few words of conclusion, few slides of conclusion. I think neurosciences can help education. We understand now a lot about reading, and we understand that in all cultures, there is not so much variability. We always have the same brain mechanisms. Reading always requires specializing the visual system for the shape of letters and connecting them to speech sounds, even in Chinese, by the way. There are no letters, but there are characters, and some of them map statistically to the sound. Teaching letter to sound correspondences is therefore essential. It's one of the main pathways which is being transformed in the brain. Brain research converges with educational research. Teaching of letter to sound correspondences is the fastest way to acquire reading and comprehension, not just, being able to decode the words. How does this work? Because it works because there is a form of self-teaching. Once the correspondences are learned, children have this correspondence between letters and sounds, then they can recognize the words auditorily using their auditory lexicon, and then this more direct route between letters and meaning can be trained. It can be self-trained as the child reads by himself, even without a teacher. So this notion of two routes of reading play a very essential role in all contemporary models of the reading process. Cognitive neuroscience